Hi, it's Jan Beta, and I'm going to try to fix this Amiga 500 revision 5 board today that I've been working on for quite a while. This is an Amiga 500 board that I got years ago, and I've been working on this. I also started making a video about this. The footage is lost on some backup hard disk. I didn't find it. I did some work on this, and I continued working on this quite recently and posted about this on Mastodon. And the thing that stopped my efforts was that the fat Agnus that I put in here just broke one pin off. I suspected it to be broken anyway. Yeah, I worked on this and a pin broke off, and I tried to solder a wire on that, and that didn't work. And I finally got a new Agnus donated by Arne, who is active on YouTube and PeerTube and also Mastodon as Root42. Some very nice retro computing videos to be found on there, and he also posts about his repairs on Mastodon quite frequently, so I highly recommend following Root42. I'm going to link that in the video description as well. The state of this, as you can see, I've been working on this for a while and it is a real head scratcher. I'm going to talk about what this does in a second. First things first, let's put the Agnus in here that I got from Arne. And you have to really be careful with these. They are delicate, and also the sockets are super delicate, so I hope I don't break another leg. Just trying to push this in evenly. And the socket I already replaced in previous repair attempts, and also I socketed and replaced most of the data path chips here. These are logic chips, and I replaced them with I tried various other chips in there, socketed them. This is what it does. It gives me a green screen, which can mean a lot actually in the Amigas. According to the error codes manual, this is a fault with the Agnus or with the RAM or with the data path. That's why I replaced so many of the chips here, because RAM is actually not that common of a fault with Amigas. I think this is a Kickstart 1.3 or 1.2 ROM that we have in here. They are basically acting the same regarding error codes. And this also, if you connect a keyboard, it also flashes the power LED. That's another sign for a RAM fault actually, or something wrong with the data bus. And yeah, let me show you what I did so far. So I put these stickers on here, which are just a printout of a PDF that I'm going to link in the video description. Super handy for when you want to poke around with an oscilloscope. These have the pinouts for all the custom chips on there. There's also one for the Agnus that has at least the pin numbers on there. And I've found out some stuff. I'm going to show that again because I didn't film that. I scoped the data lines and I found some data lines that are wonky. So let me show you that. I replaced the PLCC socket for the Agnus because that was my first suspect. These break pretty frequently and don't make good contact. The ones Commodore used originally are not of very high quality, and as soon as you put a chip in and pull it out, they are wearing out pretty rapidly and don't make good contact. That's one of the faults that's most common in my experience. Also, the same goes for the other sockets they used on the Amigas. They are just not very good. I replaced some of these logic chips in the data path because I suspected these, as I said. Let me show you the data lines actually. So I noted down that the data lines 8 to 15, this is a 16-bit data bus, obviously, that these are wonky. This is data line 7, that is what it's supposed to look like, and there's activity on there. And given that this gives me a green screen, I think the basic functionality of the processor is there. The Kickstart ROM is read correctly and addressed correctly, and it's getting to a point where it actually executes the error code. So that's what a data line is supposed to look like levels, TTL level logic that's changing around a bit. And yeah, This is basically what it's supposed to look like. This is data line 8 on the processor. And you can see these little bumps there where it tries to go up. So something is pulling that down, I think. There's a bit of activity there, but there's not enough activity. This is data line 9. That is basically the same picture. It's trying to do something, but something is pulling that down. Data line 10, same with these little bumps there. Data line 11, it's also strange levels there. Data line 12, also these little bumps. Data line 13, also some little bumps visible there. Data line 14, same there. Data line 15, the same there. And the other data lines, this is data line 0, they don't have these little bumps that we've seen there. So the data lines 8 to 15 have a problem. And these data lines are present on these data path chips here on U12 and U13. And these are more or less directly hooked up to the RAM and these other data lines here. So I'm going to probe the RAM just to show you that we have a possible problem with the RAM there. I tried the diagnostic ROM, the diag ROM, which is super helpful usually, but it doesn't even start up properly and we don't get any output through the serial port. So there's something wrong, probably in the portion of RAM that uses, and it isn't able to start up at all, basically. That means something is utterly wrong. Now, I don't feel any of these getting ridiculously hot or anything like that, but yeah, there might be a severe problem there. And as I said, I replaced all the data path chips here. I tried multiple different chips and nothing helped. And given the fact that there are multiple data lines showing as wonky, there may be one of the RAM chips. Unfortunately, impossible to determine which exact RAM chip it is, but we're at least going to try to figure out which row of RAM chips. I think they are handled separately. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication. They can populate your boards for you. Basically a one-stop solution for all the tinkerer's needs. I highly recommend checking out the link in the video description in case you're interested in such services. Back to our troublesome Amiga. So probing the RAM chips. I'm not sure what pinout they have, but we should be able to see something here. There's not much happening. Yeah, so this is our U24, the first row, the upper row of RAM. And it's basically the same picture on the lower portion here. So the RAM is definitely, there's something wrong with the RAM and isn't correctly addressed. But it's not visible which of these RAM chips is bad, actually. It might still be something else, of course. And they all look kind of as if they were trying their best. This is our data bus. That looks kind of healthy to me. So these are new chips, actually, that I put in here currently. But on U12 and U13, there's some pins that are really bad. On pin 2, for example, that's our data bus. That's basically the data bus that is going through there. And something is pulling that low. Pin 4, yeah, basically the same picture. Pin 6. These are the exact same signals that I've shown you basically on the processor. So I guess one or more of the RAM chips are toast. I don't think this has anything to do with these logic chips. Pretty much determined, because I spent so much time with this, pretty much determined to just replace the RAM chips at this point. Or at least get them all out and see if that changes anything. It might just be one RAM chip that is messing everything up, or several RAM chips that are broken. So let's desolder all these RAM chips. Not sure which one is the culprit, but we're going to see. Maybe that changes something. So these are the best schematics I could find for this revision Amiga 500. And here's our RAM chips, and you can see the data bus here, data lines 0 to 7, and the chips are U16 to U23, and U24 to U31 get the data lines 8 to 15, which are the ones that were wonky. I'm just going to try to desolder these at first, U24 to U31. And of course it might also be related to this chip here, which was my first suspect actually. But yeah, I replaced that a number of times. Maybe it's a wonky socket. I'm just going to go in and resolder or replace all these, check these individually. Just this row of RAM chips for starters. I don't know, maybe that helps. And this is of course entirely possible that these are all okay and it's something else. I'm just going to get the retro chip tester out, I guess. So the retro chip tester, 41256, these are 256K times 1. Wow, this thing does a lot of testing. The first one was actually okay. I'm just going to test the other ones as well. Takes a while, so I'm not going to do it on camera. Okay, I'm in the process of desoldering more chips, and let me show you what this gives me. This failed on the first test. So we definitely have some bad RAM in there. So this one is bad. And I'm testing the rest of the RAM chips in the background while I'm doing this work. Another RAM chip tested good actually, so it might actually be just one RAM chip that was bad. That prevented the diagnostic ROM from starting up and messed up our data lines. And I'm not sure how one RAM chip would bring all the data lines down, or the data lines connected to this row of RAM chips here. This one here might be the culprit. So I'm putting the known good ones in here. Let's see if those fit into the sockets here, I guess. Yeah, so all the RAM tested good except for this one, which doesn't even really start the test, it just stops right away. So yeah, this one's definitely borked and the other ones are alright. Okay, I am just straightening out all the legs manually with a little pair of pliers on these original RAM chips that tested okay. And I'm going to try to fit these in the sockets, hoping that they make good enough contact. I replaced one of the RAM chips, of course, with one from my parts bin that I tested in the Retro Chip Tester Pro. So that should be alright. Okay, I think I got everything back together. This is the bad one. I'm just going to permanently mark that as bad. Okay, if that was the only fault, this should now hopefully start up with our kickstart screen. I'm not too sure, but at least the RAM chip we removed was definitely a bad one. Cross your fingers. Nope, it's still a green screen. Okay, let's see if the data bus cleared up at least. Maybe try a diagram. Maybe that starts up now at least. Where is it? So diagram in place. Let's see if that gives me any output now. Yeah, no, that's exactly what it did before as well. Might want to check these logic chips actually that I put in there. Yeah, there's lots of things actually, obviously, that could be wrong with this still. Okay, let's see if we at least got those data lines behaving now. Connected the scope back up, just the exact same settings as before. Yeah, it's exactly the same with these little bumps there. This is D8. Yeah. It's pretty obvious that these are not behaving correctly. So I think what I want to do at this point is to check all these logic chips here, which are in the path. Maybe these are just not the right chips. Maybe I'll try some other ones. We'll see. So this one is good. Although the socket feels super loose, but yeah. Probably it's a good idea to replace the socket. This is another 244. 74, 244. Yeah, these should all be good because they're basically new chips. And that is also okay. Yeah, so our logic seems to be a-okay. I'm going to have to do some more probing on here, I guess. Something prevents this from starting up. But the system seems to reset properly, otherwise we wouldn't get the error handling. So this continues to stump me. Okay, I started swapping these chips and swapping this 74244 with this 74244 moved our problem to the other half of the data lines. So we now have the first couple of data lines showing the wonky behavior. D1, we have the smaller bumps there. D2, D3, D4. Yeah, so I'm pretty sure that one of these chips causes our problem. These two 74244. Just let me see if I have other chips to go in there. Should be regular 244 chips, but I'm not sure. Changing these two close to the RAM didn't do anything, and neither did changing these two. So something with these two. Messing up the data bus. This is a 244. Try these. Still the same with those data lines. So I think I'm inclined to just desolder these sockets here again. Nothing else changes anything, basically. And worst of all, I put these sockets in, so if there's something wrong with the sockets, I'm the one to blame. I think I put these in. I don't even remember in which state this was when I got it. Maybe there were sockets in there already. Anywho, these seem to be relatively timing sensitive. Putting turn pin sockets in there can actually help with that. Traces look excellent on the bottom, but we saw that before. Let's see if the traces here actually look good. No trace damage visible, at least around these. So maybe something further down the line. But the signals are somewhat coming through. It's just not the correct level of signal. I'm just going to check the connections and see if our sockets make a difference. Yeah, these connections seem to be fine. Yeah. There might be something else wonky here. Yeah, they actually sit in there much better, much tighter. Let's see if that changed anything. So, turning this on, but probably still a green screen. Yeah. Let's see about our data lines. But look at that, we don't have the black screen in between, I think. That would be kind of interesting. So data line 1 looks relatively good, data line 2 looks good, data line 3, data line 4. So data line 8 looks like this now. Data line 9 looks much better. Data line 10, data line 11, data line 12, data line 13 looks much better. Yeah, that actually made things considerably better. That's pretty nice. Still looks kind of wonky, but we get a change in behavior. We don't get the black screen in between. Let me try with the diagram. And I think I just have to replace all these shoddy sockets here. Possibly that's the reason why this doesn't start up properly. No, still the same. Yeah, I think I'm going to have to replace all these sockets. We still don't have quite the full TTL levels there on our data lines 8 to 15, but it's much better. This is a weird fault. The sockets I used are a bit loose, but it shouldn't be that bad, really. Yeah, so probably it's a good idea to replace at least this socket here as well, because that is, I think, connected to the data lines we're looking at. This Amiga is officially kicking my butt quite a bit. It's a day later and I made some changes and there is some improvement, but it still doesn't start up. Yeah, this is what it does with the diagram at the moment. Let me show you what I did and what I found out. So in the meantime, I replaced all these sockets in the data path, these two here and all of these. This is basically everything that's in the path to the RAM. And that cleaned up the wonky traces we've seen on the oscilloscope for the data path quite a bit. So it nearly looks perfect now if I probe the data lines, all of them. So that was definitely an improvement. The old sockets were like dual wipe sockets, and these are precision sockets, quite good ones that I put in here, and that definitely made an improvement. And I also, after reading through some forums, realized that these two, which are 74244 chips, are actually originally 74F244 chips, which are different to the standard 74LS244 chips that I used in here previously, in that they are faster. So that makes a difference, it seems, although the modern 74LS244 should be just as quick as these. I'm currently using 74ABT in here, which are the modern equivalent of the 74F series, which is now obsolete, so you can't really get these anymore as new chips. But ABT is what's available now, and they should be the same speed as the F series. So data lines look clean now. Let me show you on the scope. So probing the data lines again on the processor, which it doesn't matter really where you probe them, I guess, in this scenario. This is data line 0, data line 1, and we have much clearer traces. There's a bit of overshoot there, but I don't think that's changing anything. Some of these still look a bit low, like here on data line 5. But it's much, much better, much, much improved comparing it to what we had before. As you can see, there's still some like little stairs in there, particularly in data line 5. So I'm probably going to look into that a bit more. And I also noticed something else, which I'm going to address, which is I start this up with the diagram and the screen actually changes a bit until it gets green screen. But if I touch the Agnus chip, I get changes there. If I wiggle it a bit, the graphics output changes, which leads me to believe that the socket that I replaced years ago when I started troubleshooting this, because these are always kind of a common thing to fail, because these, yeah, they don't, it's pretty difficult to grab these PLCC chips with the socket anyway, and the ones they used originally are not the best quality. Yeah, there seems to be something going on there with something not making perfect contact. So I am going to replace the Agnus socket again after all these years, even though I put a pretty good one in there, but I'm just going to replace that because that's the only thing I can think of that is in the data path which might be messing up the levels there. There's kind of too much resistance on one of the pins for data line 5 maybe on this Agnus chip. It might still be the RAM, that's also in the data path, obviously. The processor seems to be fine, I replaced that with another one. I also replaced the Gary chip with another one that says okay and was tested good. The sockets, that's still the original sockets for the Gary and the Kickstart ROM. So these might be an issue. The processor socket usually is fine. The processor itself seems to be fine. The Agnus socket, maybe I'm going to replace the socket for the ROM just to rule that out. It's all guesswork at this point because I can't really see where it is failing with the tools and the knowledge I have. I'm sorry about that. Yeah, next up, replacing the PLCC socket on the Agnus again. Okay. That's a lot of pins, as I said. Okay, let's try that again, shall we? Put the Agnus in the socket. Okay, that's a more positive grab than we had before. Maybe that changes something. I don't really have high hopes at this point, but we're going to see. Nope. Now we get a green screen with the diagram. But at least we don't get... Yeah, the socket definitely made bad connection there. We don't get anything happening if I wiggle the Agnus now. So, more poking with the oscilloscope, I guess. Maybe it's the ROM socket, but yeah, it might be. It might be the Agnus, might be the Gary socket. Might still be something completely different. Not sure at this point. Maybe it's also a good idea to check the capacitors here in the data path. There's also these resistor packs next to the RAM. Should measure these. But changing the socket definitely made the wiggle thing go away. Which isn't bad. I guess that's at least some kind of progress. But it still doesn't even start up the diagram at all. Maybe I just replaced this socket, the ROM socket, because I didn't do that previously. And that feels really loose. I think I want to do that anyway, because that socket is clearly really worn out. And the data lines go through the ROM as well. More desoldering and resoldering fun. Okay. ROM socket replaced. Nope. Yeah, but it's a solid green screen now, okay? That is somewhat better, I guess. I'm not sure. At this point, I just don't know. That was the diagram. Now the regular ROM is still giving me a light green screen. Okay. that is pretty much the same that we had all along. And I'm just adding more chances for this to fail by replacing everything one at a time. Yeah, but yeah, I just don't know. Just going to scope around for some more, I guess. I searched around the forums again and I found somebody who had the same behavior in the diagram with the rainbow stripe screen and nothing else, and it was related to the Paula chip not getting the correct voltage. And my Paula chip gets a voltage, but it's a bit low. It's 4.9 volts or thereabouts, where it should be 5 volts. And now we get some different behavior here. I'm not quite sure if it's related to the other version of the diagram that I have in here. So let's put the original version of the diagram back in. Oh god, this thing is driving me nuts. Maybe it's just the Paula socket not making good contact or something. Just going to put the version of the diagram I had in there before back in. So maybe we try another Paula. I think I have another one. Maybe we just replace the Paula socket. Maybe we replace the little EMI resistor that goes through that. So there's a 1 ohm resistor here and a little capacitor next to it that filter the voltage that goes to the VCC pin on the Paula. And that is not 100% alright. And given the fact that the diagram seems to fail in this exact way, without outputting anything on the serial port, might be an issue there. Let's try another Paula. I think I have one somewhere. Okay, here's the Paula from the other Amiga that I've shown earlier. And it does the exact same. So we're going to replace that resistor and possibly that capacitor there. It looked a bit dirty around that. Maybe something's bad there. Maybe it's got something to do with our Paula. I'm not sure. So that's my best guess at this moment. And only because somebody posted in a forum that they had the same rainbow pattern. I'm going by that. I don't have any output from the diagram still, even through serial. And it sometimes stops on a green screen, which would be complete failure of RAM. That's what it means. But yeah, with the diagram, I just don't know. If it doesn't start up. Yeah, I'm also going to pull that capacitor there, just in case something went wrong there, and replace the socket, I guess. I have plenty of 48-pin sockets. In the meantime, I replaced all the RAM as well, just to make sure that that didn't change anything. The old resistor, measuring that? No, that's 1.06 ohms actually, that's okay. I'm just going to pull that capacitor there as well. Little bugger, what's that? Oh, that broke the leg instantly, basically. So maybe something was wonky there. Here's what that looks like, and the one leg that I can't find anymore because it probably fell to the ground. It just broke off on that end here by just barely touching it. That's part of the fault, maybe. At least it doesn't hurt to replace that. And 224 is 220 nanofarad, and this is a 224. Slightly different package, but it's going to be fine. And that's filtering the voltage going to the Paula. At least that's one of the stages of filtering here. Did the voltage arriving at our Paula chip actually change? Where's our VCC? Third pin from here, I think. Now it's still 4.9. So I'm just going to pull this socket. I'm not going to show you the whole process because it's boring, probably. So putting a good turn pin socket in there. So I just had an idea after pulling the Paula. Maybe it's interesting to see what happens without a Paula chip in there. But now we get this screen. Okay. That's kind of interesting. Okay, let's put the original Paula back in there that we had in there. Does it revert? Yeah, that's now the rainbow screen. Okay, so that's at least changing some of the behavior. Maybe there's something to that. Let's pull the socket and put a proper one in there. That just fell out after desoldering. And of course I didn't film. So you're going to have to believe me. Take my word for it. Okay, new socket is in. Let's put a Paula in there. Much better grip. Okay, let's see if that changed anything. Maybe we even get something on the serial port now. We're going to see. Your guess is as good as mine. Let's see. Fingers crossed. Nope, green screen. No RAM. But we can just change the RAM chips back, I guess, to the ones we had. Maybe these are not compatible. Let's see if our diagram gives us any output now. Okay, the only thing we get are these two characters that look like a Y. One character. Can't see. At least, yeah, the diagram is still not starting up properly. But if it stops at a green screen, that means no RAM is detected at all. So possibly we still have a problem with the RAM, which is basically the same problem we had all along. But at least it got a bit better. I don't know what else is wrong with this machine. We're going to dig a bit deeper, I guess. And it's still green screens with the original Kickstart ROM in there as well. So possibly I'm going to try some new RAM chips. I have plenty of those to try out. Then probably the capacitors. I don't think that's going to change anything. Maybe the other RAM bank is worth trying something in as well. I would have to desolder all those RAM chips, which of course would be super fun. I'm not sure I want to do that, but at this point I have nearly everything socketed in here, at least, which is kind of cool. So let's see. Nope, still the exact same. Okay, capacitors next, I said. So I'm going to recap this whole board, but I'm going to need a break. So it's a couple of days later and I went ahead and replaced all the electrolytic capacitors on this board with known good ones. And guess what? There wasn't any change. And I continued my journey of troubleshooting this by burning a new diagram. The new version 2.0 is an alpha version, but it has some added features that I thought might be useful for this peculiar case of Amiga 500 failure. And yeah, we basically still get the same result, just with some flashy colors that the new diagram produces. Then it goes briefly to widescreen and then we have the same pattern that we've seen all along basically, which then slowly changes. So something is happening, but the data transfer is not ideal, probably something in the data path or with the RAM still. And I've ruled out practically nothing definitively, but yeah, I think at this point my best bet is to replace the other RAM bank that we didn't replace, the other 8 RAM chips, and see if that changes anything. I got some garbled output over serial, so it's definitely trying to work, the diagram, but it doesn't start up correctly. The garbled output might be related to the Paula chip not getting the correct signals in or out. This handles the serial port, which is further handled by these two serial RS232. It even says on the board there, chips, and goes out to the serial port, of course. The new diagram 2.0 uses a higher bit rate, 19,200, I believe. But that didn't change anything other than I had to set the terminal software up to 19,200 and we still get garbage on screen through the serial and the little stripe pattern that we saw before. Yeah, garbled characters can mean Paula or the data path, something around these chips and the RAM. and the Agnus, which I believe I can pretty much rule out. But it might be some broken trace that I didn't catch. It might be totally broken RAM. These logic chips might not be working correctly. I'm going to test all of these. I guess that's probably the next step, just testing these in the retro chip tester to make sure that these ones that I put in there actually work. The levels on the data bus look way, way better than before with the new sockets and with these chips in there. I scoped around there. Yeah, I'm pretty much still stumped. I'm going to have to measure all these chips. Testing logic chips thankfully doesn't take as long as testing RAM chips. And then I'm probably going to replace all the RAM in case these are all good and go from there. I am not sure how to pinpoint this fault at all. It all looks much better than it was, but it's still not starting up. Testing some logic. And surprisingly, they're all okay. The logic chips in the data bus. But we don't know if they have the right timings. I'm not sure if that is possible to test that outside of the machine that needs those specific timings. They seem to be timing sensitive given the fact that they used the F variant in these positions here. I'm going to desolder the RAM and put sockets in, I guess, as my next shot in the dark. Those came out really cleanly. I don't think I damaged any traces or any through holes or anything. So yeah, let's test all the individual RAM chips with the retro chip tester, and I'm going to report back if I find a bad one. Chances are there's another bad one in here. Maybe that makes a difference. I don't know at this point. Yeah, and we get very much the same result without any RAM in this bank. It's probably not related to the RAM, I'd say. Green screen just means it can't access RAM, which makes sense. In this case, there is no RAM in there. But let me test the RAM chips first, I guess. Just using the Retro Chip Tester Pro, as we've seen before. And lots of patience. Unfortunately, in this case, all the RAM tested okay. So I put sockets in, just with the other RAM bank. I beeped out the connections between the RAM chips. They are all pretty much connected in series. So I beeped out every single pin on this and on the bottom row, and that's all fine. So the connections between the RAM chips are okay. The RAM chips seem to be okay, at least according to my test, which should be relatively accurate. And these are much more resilient than the older RAM chips anyway, so these don't fail as often as the ones that were used in earlier machines. Yeah, I'm not sure if I can finish this video with a successful repair and playing Turrican, as I usually do with my Amiga 500s and the other Amigas. I'm not sure. I'm just going to give this another go. Maybe something was locked up there, something shorted out. I cleaned the board a bit. Maybe there was some strange thing going on there. It's worth a shot to power this on again with the sockets in. I don't have very high hopes, but we're going to see. At the very least, we should get the same behavior as before. Yep. Screen flashes, turns white or very light gray. I think it's white actually. And then it doesn't do much. Okay, it just stays white now. But I've had that exact behavior a couple of times before. At least the color flashing works, so it's starting up to some extent. And we don't get the rainbow thing anymore. Maybe we made progress. Now the RAM chips are in a different order, of course. And I cleaned the board and knocked it about. Yeah, no more rainbow. Maybe we get something on the serial port now. Might be worth a shot. Nope, nothing on there. Hello. No progress, basically. So to be quite honest, I'm getting a bit tired of this Amiga and also a bit frustrated because there are so many things that I replaced and checked and it still does basically nothing. This is the point where I ask you for your ideas about this. So if you have any ideas, what else to check? I'm definitely going to check the whole data path, the connections on that. Maybe there's a broken trace that I missed somewhere in there that would explain why we don't get anything. So I think this is where I have to finish shooting this video because I have to release it at some point. If you have any ideas, please discuss in the comments. I'm going to read all of them, probably answer most of them as usual. And maybe somebody has some kind of idea what to try next. For now, this thing got me beaten. I'm going to sleep on it, not literally, but I'm going to have to think about this and read up some more about this particular fault. And then I'm going to be back with another part of this. Thank you so much for your time. Hope this was entertaining and a bit informative. Nonetheless, even if I didn't manage to fix it, that's what happens sometimes. It took a long time to get to this, and it's basically still the same as before. But I ruled out some stuff, and yeah, I'm going to continue this eventually. Special thanks to everybody who supports me on Patreon or on the YouTube channel memberships page or on Ko-fi or elsewhere. There's links to that in the video description in case you want to give me some support, which of course is highly appreciated because all these little sockets and things and capacitors cost money, of course. So that's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye. I was hoping to play Turrican at this point. Tough luck.